As global energy demands surge, we find ourselves at a crossroads. While modern renewables such as wind and solar are often praised as the future of clean energy, they present significant challenges in terms of efficiency, grid stability, and battery storage. Meanwhile, nuclear power, the most reliable, efficient, and safest form of energy humanity has created, remains underutilized due to misinformation, political bureaucracy, and corporate interests. This article will explore why nuclear energy is essential for sustaining modern civilization, debunk common myths about its dangers, highlight the advancements that make it safer, cleaner, and more efficient than ever before, and examine nuclear disasters in context, proving that nuclear remains the safest energy source despite past incidents. While wind and solar energy play a role in the clean energy transition, they suffer from inherent flaws that make them unreliable as primary energy sources. Unlike nuclear and fossil fuels, wind and solar are intermittent. They generate power only when the sun shines or the wind blows. Large-scale deployment of renewables requires an extensive network of batteries to store excess energy. But battery production is costly, environmentally damaging, and resource-intensive. Countries with high renewable penetration, such as Germany, have struggled with grid reliability and often rely on coal or gas as backup power, negating much of the climate benefits. Solar farms require vast amounts of land, often leading to deforestation and habitat destruction. Wind turbines disrupt ecosystems, cause bird and bat fatalities, and require significant mining for rare earth materials. Battery production and disposal introduce pollution risks, including heavy metal contamination and toxic waste. Contrary to popular belief, nuclear energy is not only one of the cleanest energy sources but also the safest. Let's examine the numbers. According to studies conducted by the World Health Organization and Our World in Data, coal, 24.6 deaths per terawatt-hour, primarily from air pollution. Oil, 18.4 deaths per terawatt-hour. Natural gas, 2.8 deaths per terawatt-hour. Hydropower, 1.3 deaths per terawatt-hour, mainly from dam failures. Wind, 0.04 deaths per terawatt-hour. Solar, 0.02 deaths per terawatt-hour, from mining and manufacturing accidents. Nuclear, 0.007 deaths per terawatt-hour, making it the safest commercial energy source. One of the biggest fears surrounding nuclear energy is radiation exposure. However, most people don't realize that everyday activities expose them to more radiation than living near a nuclear plant. A single long-haul flight exposes passengers to more radiation than living next to a nuclear reactor for an entire lifetime. In contrast, coal plants release more radiation into the environment than nuclear plants due to natural uranium and thorium in coal ash. Nuclear power's reputation has been tarnished by high-profile accidents, but these events are extremely rare and mostly caused by human error and outdated technology, rather than inherent flaws in nuclear energy itself. The worst nuclear accident in history, but it occurred due to a flawed reactor design and human mismanagement. Modern reactors are physically incapable of experiencing a similar explosion due to inherent safety mechanisms. Estimated death toll, between 4,000 and 16,000 over decades, mostly due to long-term radiation exposure, which is far lower than annual deaths from coal pollution, over 1 million globally. The disaster resulted from a massive tsunami, not an internal reactor failure. There were no direct deaths from radiation exposure. Most health impacts came from the evacuation itself. Post-Fukushima, reactor designs now include passive safety features that prevent meltdowns even in extreme conditions. A partial meltdown occurred, but no deaths or long-term health effects were recorded. The event led to regulatory improvements, making reactors safer than ever. Modern advancements in nuclear technology are addressing many of the criticisms against older reactors. Here's how nuclear power is evolving. Small modular reactors, or SMRs, are cheaper, safer, and scalable, making nuclear energy more accessible. Molten salt reactors, known as MSRs, operate at lower pressures, reducing the risk of meltdown and increasing efficiency. Thorium reactors utilize thorium, which is more abundant than uranium and produces less long-lived radioactive waste. And then there's nuclear fusion. While not yet commercialized, fusion energy promises limitless clean power with zero meltdown risk. Another common myth about nuclear energy is that it produces unmanageable amounts of dangerous waste. The reality is, over 90% of nuclear fuel can be recycled and reused in reactors. France, for example, recycles nearly all of its nuclear waste, reducing disposal needs. Waste storage is safe. Spent fuel is stored in reinforced concrete casks and underground repositories, ensuring long-term containment. Despite its clear advantages, nuclear power has been hindered by political roadblocks, misinformation campaigns, and corporate lobbying. Investigations suggest that some anti-nuclear protests, particularly in Europe, were funded by fossil fuel interests seeking to eliminate competition. The closure of nuclear plants in Germany, for example, led to increased coal and gas use directly benefiting the fossil fuel industry. Excessive regulations and red tape make nuclear plants costlier and slower to build compared to fossil fuel and renewable projects. In contrast, China and Russia are rapidly expanding nuclear programs due to streamlined approval processes. If we are serious about tackling climate change, ensuring energy security, and sustaining civilization, we must embrace nuclear power. The evidence is clear. It is the safest, most reliable, and cleanest large-scale energy source available. Advancements in nuclear technology are making it even safer and more efficient. Misconceptions about radiation and waste are largely unfounded, and the main barriers are political and corporate interests. The time for action is now. Instead of shutting down nuclear plants, we should be building more, investing in research, and ensuring that humanity has the stable, abundant energy it needs to thrive in the future. Nuclear power is not an option. It is a necessity.